Hello everyone, Aj welcome back to the channel of ED Magic. Today we are going to start with the chapter Work, Energy and Power. First of all, we need to learn the definition of work. What is work? So work is defined as force into displacement. Means that if there is an object in front of me, let's suppose this is the notebook, this is an object, and if I am applying force on it, then it got displaced. Such a phenomena in which when I am applying the force and the object gets displaced is known as work done. Okay. According to the definition of physics, work is defined as the dot product of force and displacement. It means that work is equal to Fs cos theta. Theta is the angle between force and displacement. For example, this is a force. If I am representing this pen as a force and force is applying on this object in this direction and get it displaced. So here we will multiply force, displacement and the theta between this pen, that is the force, and this notebook where the displacement occurs. Okay. Now the work unit, we all know the SI unit of work is joule. Okay, and it can be also termed as Newton meter according to its. Now work can be positive. Work is defined as positive when force and displacement are in same direction. Work is defined as negative when force and displacement are in opposite directions. And work is defined as zero. Work is defined as zero when force and displacement, either force is zero, either displacement is zero, or either both are zero, or either theta is 90. Sorry, theta is here. Theta is 90 because cos 90 is 0. Okay, for example, if I am throwing this pen upwards, okay, then the work done by gravitational force will be negative because gravity is acting downward and the displacement of pen is upward. But when I am dropping this pen from upward to downward, then the work done by gravity is positive because force of gravity is also in downward and the displacement of pen was also downward. Okay, so in first case, when the pen was being thrown, it was negative work done by gravity, and when the pen is dropped, the work done by gravity is positive. Okay, work done zero, what will the case? For example, we are taking theta, let's suppose theta 90. Let's suppose there is a wall in front of us, and if I'm applying constant force on it but the wall is not moving, so displacement is zero. Okay, so these are some cases. And one case of friction also. You all know friction force that acts opposite to the motion of object. So if object is moving in this direction, then friction force will act in this direction. If object is moving in right direction, then friction will act in left, and if object is moving in left, then the friction will act in right to resist the motion of the object. Okay, so in that case, you know that the displacement of object is in right direction and the force of friction is in left direction, or you can say that displacement of object is in left direction and the friction force is acting in right direction. So displacement and friction force, so force and displacement direction is opposite, so I can say that the theta is 180. Theta is 180 now. Force is acting in this direction, displacement is acting in this direction, so theta is 180. So the work done will be minus Fs because cos 180 is minus 1. Okay, then let's suppose if I am this formula is applicable if force is constant, but if I say force is variable, means I am changing the force continuously, sometimes increasing, sometimes decreasing. Okay, so when the force keeps increasing, keeps decreasing, then this formula can't be applied because it's for constant force F. Here the force is variable, so in this case work done is equal to F dx limit x2 to x1. Okay, so force into dx, and there will be integration here and it will take place. And one more thing to notice, that area under force displacement graph gives work done. It's very important. You have to find out the work done of force displacement graph to find out the work done. Next, there is conservative force. What is conservative force? Conservative force means that the work done in a circular path is zero, or you can say that it depends on initial and final position. You can say that it is path independent. It is path independent means that it doesn't depend on path, it depends on initial and final position. Okay, third thing, it that in a circular path, or you can say closed path, sorry, not circular, closed path. In closed path, total work done is 0. Okay, so conservative force depends on initial and final position, but it doesn't depend on path. Whereas non-conservative force, there's one more kind of force, non-conservative force. Non-conservative force does not depend on initial and final position, but it depends upon the path. Okay, non-conservative force depends on path, but conservative force depends on initial and final position. Okay, and in non-conservative force, the work done in closed path is not equal to 0. So example of conservative force is a gravitational force, we have magnetic force, and what we have elastic force as well, that acts in spring. Okay, gravitational force, how come? When you are throwing the object from downward to upward, then the force is minus mgh. Sorry, the work done is minus mgh, because here force and displacement are in opposite direction. So here work done will be negative, minus mgh. And when the object will fall down like this, then force is also downward and displacement is also downward, so work done will be positive. So hence the work done by gravitational force will be plus mgh. So minus mgh plus mgh will be 0. So net force in gravity is 0. Okay, and same for elastic force, minus half kx square plus half kx square will be equal to 0. In non-conservative force, the examples can be friction force. How come? See, if you are going from A to B, then also the friction force will be minus Fs, and if you will come from B to A, then also the friction force will be minus Fs, because it always acts opposite to the direction of motion. So always the theta will be 180. Theta will be always be 180, it can't be 0 to make it positive. So in both the cases theta will be 180, so it both will be negative value, and hence minus 2 fs will be total work done, which is not equal to 0. Hence work done in closed path is not equal to 0. Another example can be air resistance as well, it can be tension force as well, it can be whisper force as well, whispers force. Okay. In a conservative force, electrostatic force can also be example. Then if we come after it, then it's power. And same for inclined plane also. If you take an inclined plane and if you take a block, mg acts here, you will take theta here, it will be mg sine theta. And if total displacement is L, mg sine theta into L will be the work done. mg sin theta into L. Okay, so I can write down sin theta. If I take sin theta A B C, it's theta here, so sin theta will be AC upon AB, and length is AB. If it is traveling AB now, so AB cancel, MGAC, and you know what is AC? AC is h, height, so MGH. And if I am taking this one, then it also be MGH. Here also, if I am taking this height as h, the work done will be by gravity will be mgh. So hence gravitational force is a conservative force because it doesn't depend on path, whether it's inclined plane or whether it's a normal path. Okay, power. So there are two formulas to learn in power. Power is equal to dw by dt. Second thing, it's the it's the slope of work time graph. If you are plotting work and time, then its slope will be equal to power. Okay, and third thing, power is the dot product of force and velocity. How come? dw, you can write out d fs by dt. So ds by dtf, ds by dt is velocity, so f dot v. I can write down fs fv cos theta also. So it's dot product of force and velocity. So force and velocity dot product is also power, and dw by dt is also power. And power's SI unit is watt. Okay, and another unit of power is पावर की एक और यूनिट होती है, देयर इज वन मोर यूनिट ऑफ पावर, दैट इज हॉर्स पावर. 1 horsepower is equal to 746 watt. That you have to remember. There are two units of power, sorry, there are many. Watt is the basic unit, then is kilowatt, that is 10 to power 3 watt. Then we have horsepower, which is equal to 746 watts. Then we have kilowatt, or also that is equal to 3.6 into 10 to power 6 watts. Okay, I think that was joule. I misinterpreted. Then it's kinetic energy. What is kinetic energy? Kinetic energy, let's do its derivation. Kinetic energy, first of all, you all know force is equal to mass into acceleration. ठीक है. W is equal to force into displacement. I can write down. And for small work done, there will be small displacement. So dW is equal to F. I can write down ma ds. Okay. A can be written as dV by dt. ds. ds by dt can be written as V. So mv dv. Integrating both the sides here, W to W1, so it will be work done is equal to here, and work done can be also written as kinetic energy, because work done and energy are both the same things. Integrating from u to v, so v square by 2 vu. So kinetic energy is equal to half mv square minus half mu square. If initial velocity is 0, then kinetic energy is equal to half mv square. Okay, if I multiply mass up and down, then kinetic energy will be equal to p square by 2. Okay, next is the work energy theorem. Work energy theorem says that work done by all the forces is equal to change in kinetic energy. Work done by net force, where work done by all the forces is equal to change in kinetic energy. Okay. Then we have potential energy. What is potential energy? Potential energy takes place when either the position got changed or the configuration. When the position got changed, we say it's a gravitational potential energy. Okay, and gravitational potential energy is equal to mgh. Example can be water stored in tank at height. And if I say shape, in shape it is known as elastic potential energy. Okay, example can be spring, the spring force. Now it's a very important thing to note that in a spring, when I apply a force F, then it will be directly proportional to displacement of spring. Okay? When I'm applying force on spring, it will be proportional to displacement. So when I will remove the proportionality sign, I can write down a constant, and this constant is known as K, which is known as spring constant, or you can say force constant. And here minus sign indicates that displacement and force are in different direction. If displacement is it's a, let's suppose it's a spring. Okay, it's a spring, and I am just a second, and I am clear visualization, and I am stretching it. I can't show now. Okay, and if I'm stretching it, okay, then you will see it will elongate. Okay, it will elongate. So the displacement will be, let's suppose, in this direction, then the force will act in this direction. Okay, so force displacement are in different directions, then the work done will be negative, hence minus sign came off. Okay, so force that acts on the spring is directly proportional to the elongation or compression. X is here, x क्या है यहाँ पे, x is elongation or compression. कि जब मैं when I will apply force on spring, then the spring will either get compressed or it will either get elongated. Okay, so this force, the force that I am applying on spring is directly proportional to the compression. मतलब मैं जितना ज़्यादा फोर्स लगाऊंगा स्प्रिंग में, उतना ज़्यादा स्प्रिंग कंप्रेस होगा, और जितना कम मैं फोर्स लगा रहा हूँ उतना कम वो कंप्रेस होगा. ऑफ कोर्स पता है, यू कैन ट्राई इट प्रैक्टिकल एज वेल. ओके, and after that okay, This we have done. Okay, let's derive it as well. So work done is work done is equal to force into displacement. So for small work done I can f dx here integrated w2 w1. So w is equal to f is minus kx dx x2 to x1. If I am taking it from x2 to x1, so it minus will come out, minus k will come out, and x square integration, so it will be x square by 2 from x1 to x2, x2 to x1. So hence the net work done will be equal to half k x2 square minus half k x1 square. Okay, if x1 is 0, means if I am starting, if spring was in rest, if spring was in mean position या रेस्ट पे था, तो वर्क डन बाय स्प्रिंग इज इक्वल टू हाफ के एक्स टू स्क्वायर या फिर हाफ के एक्स स्क्वायर एंड स्प्रिंग फोर्स इज इक्वल टू माइनस के एक्स. दैट यू हैव टू नोट. ओके, so if I will plot it on a graph, then I can say like this: it is 0, it is x, it is minus x, and like this. half kx square minus half kx square. ठीक है, it's a potential energy versus displacement. On x it will be half kx square, on minus x it will be minus half kx square, and the graph will be like this, parabolic, passing from origin. Okay, if I am compressing or elongating it in a positive direction, it will be plus half kx square, and if I am elongating or compressing it in negative direction, it will be minus half kx square. Okay, then we have topics like collision as well. What is collision? Okay, we all know collision, then when two things, just they got smashed, they got hit. If there's an object m1 moving with u1, m2 moving with u2, after their collision, let's suppose m1 moves with v1 and m2 moves with v2. Okay, if the collision is there, collision are of two types, elastic and inelastic. In elastic collision, what happened is, first thing, momentum got conserved. In elastic, momentum got conserved, means m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Second thing that happens is kinetic energy remains conserved, means there is no loss of kinetic energy. Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Third thing, let's see it. Okay, if collision is inelastic, then only one thing will happen, that is momentum will remain conserved. Why? Because there is a loss of kinetic energy. So if kinetic energy is being loosed, then of course you can't conserve it. Okay, so m1 u1 plus m2 u2 is equal to m1 v plus m2 v. Second thing to note is that the final velocities remains same for both, means it doesn't matter if the initial velocity of both m1 and m2 was same or not. But in elastic collision, in inelastic collision, what happen is the final velocities of both objects become same. ठीक है, in elastic collision, the first one, momentum remain conserved and kinetic energy remain conserved. In inelastic collision, first thing, momentum remains conserved, and second thing is that there is a loss of kinetic energy, so kinetic energy cannot be conserved. Third thing to notice that the final velocity of both the object became same, but the initial velocity may or may not be same. Okay. There are two formulas for you all to learn. Okay, there are two formulas for you all to learn. First formula is of v1. v1 is equal to m1 minus m2 upon m1 plus m2. v2 is equal to m2 minus m1 upon m1 plus m2 plus m1 plus m2 plus m2 remains same. For v1 you will write m1 first, for v2 you will write m2 first. Okay, plus 2 m2 u2 upon m1 plus m2. m1 plus m2 will remain same for all, m1 plus m2, and here 2 m1 v1 m1 u1, sorry, v is here na, so you will write u. So for v1 m2 u2, for v2 m1 u1. I hope the thing is clear. Then there are many cases that to be followed. First case is that case 1 is if m1 is equal to m2 is equal to m. If both the masses are same, then you will say that the velocity got exchanged. You will put m1 is equal to m2. You will observe that v1 will be equal to u2 and v2 will be equal to u1. Case 2. Okay. When u2 is equal to 0, that is b is at rest, what will happen? If you will say about v1 and u2 is equal to 0, you will say that it is equal to m1 minus m2 u1 upon m1 plus m2. And what will happen to v2? v2 will be, u2 is 0, so it will be 2 m1 u1 upon m1 plus m2. If case 3 is there, case 3 is that b is at rest, I can say that u2 is equal to 0, but I am saying that mass of b, m2, is greater than m1 very much. So what will happen? We will consider m1 as 0. So what will happen? v1 will be minus m2 upon m2 u1. So v1 will be equal to minus u1. And what will happen to v2? See, m1 will be 0. So when m1 will be 0, what will happen is m2 minus m1 upon m1 plus m2. So m1 will be 0. So m2 by m2. So v2 will be equal to u2. And u1 is 0, I think, है ना? Sorry, u2 is 0. But m1 is 0. So m1 is 0. So 2 m1 u1 upon m1 plus m2 term will be 0. So v2 will be equal to u2. Means that the heavy object will remain its same speed, but the object with lighter weight will be rebound back with the same speed. Minus sign indicates that it will rebound, means it will move in opposite direction, but the velocity will remain, the magnitude will remain same. Okay. Case 4. Case 4 says that both objects have same mass. I have already told. Acha, both have equal mass and B is at rest. It means U2 is 0. Here you have to put na then. Both have equal mass. It's saying that both have equal mass. So of course V1 will be equal to V1 will be equal to U2. But U2 is 0, so V1 will remain 0 and U2 and V2 is equal to U1. V2 will be equal to U1, but V1 will be 0 because V1 was equal to U2. U2 is 0, so it will become 0. Case 5 is that B has negligible mass and at rest. Means here mass of B will be considered as 0. M2 will be considered as 0 and U2 will be 0. So what will happen? V1 will be equal to U1 and V2 will be equal to, here this term will get cancelled, this term will get cancelled, so minus U2. So U2 is also not 0. Then here 2 M1 U1. M2 is 0. Here will be equal to 2 U1. I was putting in the formula. So V1 will be equal to U1, V2 will be equal to 2 U1. Means the final velocity of second object will be equal to the double times of the first initial velocity of the first object. Okay. Then we have 2D. For 2D, what will happen? You have to conserve it angularly. Like there is M1 moving with U1. There is M2 moving with U2. After collision, what will happen? Let's suppose they break here. Okay, let's suppose they break like this. M1 U1 and they rebound with theta 1 and theta 2. So I can say m1 u1 plus m2 u2 is equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2. I am conserving the momentum in x-axis. In y-axis the momentum will be like it's 0. Here it will be 0. m1 v1 sin theta 1, this one. And if here I am taking downward, so it will be minus m2 v2 sin theta 2. Both angle will be different. The thing to note down is both the angle will be different. If the collision is elastic, then the kinetic energy will be also conserved. Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Elastic. And for inelastic, what will happen? You will take half m as common, and v1 square plus v2 square will come together. Okay, I hope it's fine. Let's move ahead. In inelastic collision, I am taking the topic again. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 because momentum remains conserved. Okay. If I am saying u2 is 0, if I am saying second object remains at rest and the first object is approaching with some velocity, then m1 u1 is equal to m1 v1. And if I am saying inelastic means the velocity will remain same. The final velocity will remain same. In inelastic, momentum will be conserved and final velocity will remain same. In first type, elastic motion, the momentum will remain conserved and kinetic energy will remain conserved. Okay, here I can take common v as common, m1 plus m2. So v will be equal to m1 u1 upon m1 plus m2. Okay, there's one more derivation from an exam, that loss of kinetic energy is equal to. So loss of kinetic energy will be half m1 u1 square plus half m2 u2 square. Because it's in inelastic, because in elastic kinetic energy loss takes place now, minus half m1 v square plus half m2 v square. It will be 0. Half m1 u1 square minus half v square common, m1 plus m2. You will put value of v from here, you will get the answer m1 u1 square m1 plus m2 minus 1 upon 2 m1 plus m2. Okay, this will be the answer. The chapter gets over. Next video will be on numericals.